start with our session 2, which is biofuels. The moderator will be Mr. Ravi Seethapathy. I would like to invite Mr. Ankur Naik, Director Corporate Affairs, PRESPL, on the stage as our esteemed speaker. Mr. Amitabh Malaviya, CEO, Araville Green Energy Ventures Private Limited. Welcome, sir. Mr. Cyro will be here as our speaker once again. And Mr. Barbara, Associate Professor and Coordinator of the Digital Agriculture and Energy Laboratory, State University of Campinas, UNICAMP. Welcome, Barbara.
So we had, Cyro mentioned there were 5 areas of cooperation. First one was loss reduction. The second is the biofuels. And I think it's a very important area for India, as it was for Brazil at that time, simply because a lot of our oil and petroleum is used for the transportation sector, and bulk of our production and the generation is thermal and, of course, now solar and renewables. So it is extremely important for the government as a policy aim to actually have import substitution in the fuel sector, just so that they don't have to pay in US dollars to a foreign company for importing of petroleum. So that is one of the objectives that we have here. So this session also is equally important. And at the end, I hope you will ask some good questions so that we'll see how both the countries can benefit from it. So what I'm going to do is I'm going to let our 2 guests start first, and then we will come up with our host solutions. So I'm going to ask Cyro to first come and open it up, and then after that, Barbara, you will go.
Again, thanks again. I would like to start complimenting Ravi again, an old friend, Mr. Monish Ajua, the Managing Director of Punjab Renewable Energy, Mr. Amitabh Malaita, again, Barbara, my colleague from Brazil. And the idea is to give a very broad and general starting presentation talking about the experience of Brazil in biofuels, okay? A very broad idea. Yeah, sugarcane ethanol is the main biofuel used up to date in Brazil, okay? And we started on the first oil crisis in 1973, aiming to substitute imported gasoline in a program called Pro-Alcohol, okay, that started in 75. The transportation use for mobility and vehicles, particular vehicles, is peaked on 86, but right after, dramatically dropped until the decade of 1990s. Because the price of imported oil was reduced, international price. And in 1999, we developed a new technological solution with the flex motors, flex engineer that can use either gasoline or ethanol. And that's our current main technology used throughout the country, and a very successful program, and there is a massive industry of vehicles with dual fuel as a normal state in the country. Well, the sugarcane production grew a lot with the growing of this program and also sugar production. And by the 90s and the decade of 2000, the 21st century, we started connecting those plants, cogeneration plants, through our electricity systems. We had a big challenge by 2001, 2002. We have a massive energy crisis, rationing in Brazil. And the biofuels were an opportunity to get assured green energy available in the sugarcane plantation and ethanol production. And we successfully developed technology to increase the efficiency of power generation for that plant and to create economic value to afford their connection to the electric system, because in the rural areas, each generation plant was waiting for the next to ask for a connection. The first piece was a full cost connection, and then we divided. We created a normative, and I'm honored to have participated on that movement. We create a shared costs to connect a large number of plants in the country by that time, okay? In 2004, also biodiesel was adopted in Brazil, also reducing national dependence on diesel price. And the source is the vegetable oils, and also biodiesel is largely used also in Brazil now, in both as in pure state and mixes. And today we have 14% of biodiesel dissolved in our gasoline. This was used to be 12, and it's being raised recently, okay? The program RenovaBio was mentioned in the inaugural session of this. Okay, this is important. It's a very important policy, public policy mark in 2017, seeking to promote expansion on biofuels in the country's electricity matrix. Okay, and there are goals, annual goals to be reached, and RenovaBio, I think it's an example of a public policy that is providing great results for the country, okay? There are also decarbonization credits tied to RenovaBio. I will not go into the details, but you have these on my materials, okay? And recently, just to mention, his important mark was the Global Business Biofuel Alliance, and there was signed an agreement signed between the two governments. Here you see the ministries of energy from both countries signing this on January 2024. So this is a very important discussion, because I think I can envision great business opportunity between Brazil and India, and a protagonism around the other countries in the world in both programs. Both we are large countries with specific challenges on the area. I will go just for one additional point that I think it's very relevant. Brazilian electricity matrix is largely renewable. More than 94% of our electricity comes from sustainable sources, okay? And biofuels represents 80.38% of our energy production today. This is a very significant participation, and providing complementary seasonality with other sources, and also providing flexibility services, dispatchable energy, while we have the increased penetration of different variable sources, okay? These are the numbers in, that's the same graph. I think it is an interesting material to keep sharing. And that's the brief overall vision. So Brazil is in the biofuels area more than 50 years now, and we have challenges coming, and we will be glad to be working together with you, hand in hand. Thanks a lot.
Ashima. Good evening, boa tarde, buenas tardes, namaste. It's an immense pleasure to stay in this fantastic country, to meet the India, New Delhi, and the Taj Mahal. It's impressionant country and the people, fantastic people. Thank you for the organization of the grid, of the smart grid in India. Sir Ravi. Thank you for Cyro, but in Portuguese is Cyro. This is the new name for Cyro. It's very chic, elegant. Thank you for the opportunity to me here in this event. I working in the Estadual University Campinas, State of São Paulo. This is the second big university in Brazil. I working specifically in the College Engineering Agricultural. In this presentation, I talk about the introduction to biofuels, because this thing is very, very big and is only 50 minutes in this presentation. But the topics of the presentation is around the biofuels in the world, and specificamente ethanol and biofuels or biodiesel in Brazil. Some considerations, projections, and other questions about this. National Program of Biodiesel and Use of PNB is important program in Brazil. Challenges, innovation, and technological advancing in this area, cases, and one important part of the presentation is talking for you about the university, UNICAMP, as living laboratory for the energy transitions. Well, it's more big here. The production of the biofuels in the world is increased growth year for years. It's possible different conditions between advanced economics of countries or others considered emerging countries or economy. In this case, you can see India and Brazil in the first, in the important position in this in production and growth. Brazil and India, the countries is very, very more points in common. For example, ample domestic feedstock, production capacity, relatively low production costs, relative, and public and private policies. In Brazil, Cyro, in the introduction, talk about this. In Brazil, the gasoline has 27% anhydrous ethanol added. And the flex car is important advances in the use of the hydrated ethanol, because this situation contribute to the clean energy in the world, in the country. In Brazil, the production of ethanol is big and increase, and different projection refers the growth for the more percent to compare of the actual situation. And the other possibilities, for example, ethanol of corn, is increase year for year because it's necessary in some time the sugarcane, the all sugarcane production is now possible use for production ethanol because this subministers sugars, biomass, and other products, important products for the Brazil. And this is very interesting, the growth of the production of ethanol of corn. And the development, the new biofuels, and increase the production in Brazil is to the reality in this moment, and different projects. Talk about the 16% more growth in the próximos years. And in this moment, the principals the more participation of the feedstock in production of biofuels in Brazil is soybeans, soja, corn, sunflower, peanuts, cotton, canola, castor beans, babaçu is typical feedstock in Brazil, palm, dendê, macaúba is a typical Brazilian tree, and the cooking oil used is used too. But the national biodiesel biofuels program in Brazil is mandatory the addition of the fuels, different quantities, grow this quantity since various years in this condition. What is the goals, the objective this program? Social inclusion for the farmers is important part of the economic in Brazil. Regional development and generating economic incentive. New jobs and income. Finding sustainable alternatives for the fossil fuels to reduce the emissions, and support the technologies to improve the local development. And the other programs, Renova Bio, Cyro talking about this, is the other important programs of government. After the implementation, the use of fossil diesel decreased more 3%. And increase the decarbonization credits, is important situation in Brazil, and decrease approximately 80% the greenhouse gas emission in 2022. At the Brasil, the prognostic is the reduction of the greenhouse emission to 40–80% by 2025. But what is the changes in the moment, possibilities, the innovations, reduce dependence of the foods for targets, and increase the use of non-conventional this material, for example, industrial, agricultural, forestry waste, and the others, increase the productivity per hectare, develop advanced technology to produce biofuels into high quality with efficient and economical way, reduce cost. It's very important. Biofuels then used in the engines and motors, agricultural tractors, domestic car, anywhere, without need major modifications. And biofuels with physical and chemical properties similar to those of fossil fuels. In this way, the biofuels on the new generation is one possibility. The first generation, ethanol, biofuels, or biodiesel, biogas, and the other renewables diesel, when the corn, cane, sugar cane, and the other. But the second generation is the possibility of production using the sugar cane with feedstock, but increase the technical development, but increase the productivity or the quantity of ethanol produced for 2 hectares of planted. Others possibility, biometano, biohidrogênio, and the others possibility. Third generation use algas, is the other interesting way. And the fourth generation is based in genetic exchange, chemical process, new chemical process, and the others. But what is the innovation and technological advancements in Brazil in this idea of production or increase the production biofuels? Genetically modify crops, new yeasts and bacteria to improve efficiency, reduce byproducts and optimizing the conversion of sugar to ethanol, increase the biodiesel production from other type of wastes and non-endable sources. Second generation, for example, using the cellulose to produce more ethanol in the higher yields without additional lands. Hydrotreatment vegetable treatment, the IGVO technology and double distilled fat acid methyl ester to FEM, the new biofuels. And grow and harvesting technology for the algas are undergoing significant development in Brazil, some research about this. And investment in green hydrogen production. In this, you can see in this figure, the different regions of Brazil and the potential research and the potential production, independence of the different conditions in Brazil. New feedstocks in Brazil, or the BREV program, Brazilian agave development. Agave is the plant used for the producing tequila, okay? But different studies in this moment, the UNICAMP, Shell Brazil, and Senai Climatec signed one agreement and different research to be have in this moment about this to produce ethanol from this agave. Is promise for possibility. The other, sorry, yeah. Other possibility is independence of the region of Brazil, user of winter cereals with barley, rye, oats, and the tricale. Tricale is cross between wheat and rye. The organs, the government incentivate these policies and the research and development. In specific, BH company in this moment produce a big quantity of the new biofuels. The UNICAMP agreement with this company too. This situation in the Rio Grande do Sul. From the next year, process more quantity of cereals to produce millions and millions of liters of ethanol. This is very important in this moment in Brazil. Recently, the Raicen is group, private business in Brazil, the big group, anunciou de receive the certificate to produce the sustainable aviation fuels, SAF. The SAF is responsible for the more quantity of emission of the environmental. Is possible reduce 18% in comparing to the using fossil-based in fuels. The rising company, Turkey is the first company in the world to produce more quantity of these combustible fuels. Other possibility increase in Brazil is green hydrogen. In these days, in the last December, the company Green Energy Park and Solatio, and you say the construction in Piauí, Teresina, in north of Brazil, big company to produce green hydrogen, and very expectative on this possibility. Well, the University of Campinas to converge in the living laboratory for the transition, energy transition, different actions web developing with specific São Paulo Center for Energy Transition Studies. I am one coordinator on this, with financial support of FAPESP. FAPESP is the important agency for public financial research in São Paulo state. But this center on the other centers is a model the public-private partnership, PPP. This center developing different studies. You can see the age in each age the different studies. A group the research professors, students at different level, partners, private partners. In specific, the age seats, I work in this age. Transition to renewable energy and bioenergy, agricultural machinery, and decarbonizing agriculture. In Brazil, the agriculture is very important, as it's a big production, big quantity of land. And the Mahindra Indian is the group. Is the big group present in over 100 countries and stay in Brazil. And in the laboratory I coordinate digital agricultural and energy laboratory. I have one tractor of Mahindra. The marker of the agricultural machinery in Brazil is increase year for year, more. And the Mahindra is the 5th position in Brazil. In this moment, Mahindra is a building factory in the sul of Brazil, you know? Okay. Because, for example, this is in this moment, some students with my coordinate in this laboratory, and this is Mahindra tractor. This is in the laboratory of the UNICAMP, and different studies for this tractor, instrumentation tractor, incorporate the communication, Wi-Fi, digital computer, and the others possibility, because this tractor is very used in the agricultural domestic or familiar agriculture. Is the medium capacity, and the studies is have with the new biofuels produced of the BH. I talk about is the new generation biofuels, and the expectative is very, very positive. But the possibility these tractors and the Mahindra tractors and the others companies use only biofuels. Only biofuels. No more the others diesel or the others possibility. Yes? Okay. You talking for you in the future the results. Other important action in the UNICAMP University is the Campus Sustainable Campus University. In this project, two, public-private partnerships is the good model. Increase the substitute, the lighting, install the photovoltaic generation, install the system on the supervisor, monitoring sensors of the different water, electric energy, and the others sensoring. To the last year, the cost savings without generation, efficiency, replanted contracts is very, very high for the university. It's very good action. For example, some buildings in the university campus, install solar panels and generate electrical energy. And the other possibilities is very good for the students, professors, is the electrical mobility into the campus. This bus circulate between all campus, university campus, no pay. The students, no pay. Free. And in the UNICAMP, you can see this figure is the scheme, the layout, then between the abasteced post and into the camp. Okay. Wow. Other two centers in this moment under analyze in the FAPESP is the São Paulo Center for Studies in Biogas and Bioproducts and the Lighting Center for Smart Cities. The two centers develop different technologies, system, device, applying IoT, LEDs, automation, data science, artificial intelligence, but the study and generate new business, and not only academic project. The project is a more generate new business. The test and the system developing in the camps is test check, calibration. The other implementation is the important for replicate for the society. Well, my consideration, but is some. In Brazil, the biofuels provide around the 18% of total energy in this moment. Advancing in technology and infrastructure support is sustainable ground. The collaboration between India and Brazil can bring common benefits considering the expertise accumulated in bioenergy between countries, to both countries. The university has living laboratory, facilitates the developing and innovative technology and business. And the UNICAMP University are one living laboratory for the energy transition. But this is UNICAMP in the night. This is very, very photography. This is my email, and thank you.
Good evening, everyone. My name is Ankur Naik, and I represent a company called PRESPL. Thank you so much for giving me the opportunity to come on this dais. And I hope today, after we go out, whatever few little audiences we have, we get more energized and entertained about what biofuel and biomass can do for your lives. Of course, I saw the motive of doing this, and I saw a few pointers being included, including Global Biomass Alliance, biofuels, technology, etc. So I will try to touch a few points on this and ensure that by the end of this talk, Aisha, who's not feeling well because of some problem, maybe because of air pollution, gets entertained and more intelligent about what we can do to solve these problems in future. So with this, why do we basically need India or for say Brazil to have a good energy mix, and why should we need biomass or biofuel as an alternative? So of course, this is the only round-the-clock renewable energy source. There is no other renewable energy source which is available round the clock. So till the time we all eat our food, agri-residues would be produced, and this particular biomass will be available for you to convert into each and every form of energy the way you want to utilize it. Of course, it always helps in the diversification of energy resources. The Brazilian counterparts did mention about the rural development and circular economy. Of course, environmental benefits is known to every one of you. Waste management, the most effective way of doing waste management is this. And my friend, Mr. Amitabh, will then dwell upon what we call on carbon sequestration. So I will leave it to him to explain to the audience what we do about it. But so what we do in PRESPL is, we started in 2011. We started as a biomass supply chain company, and then we moved on to biomass assessment, densification. Today we do all kind of biomass projects. Of course, we are invested by Responsibility, invested by SBI, Cap Ventures, Shell, and Mitsui, who are our strategic investors today. We have 5 business verticals, which includes consulting, Densify, Boot and O&M, future fuels, which we dwell into now, biogas, biodiesel, bioethanol, and SAF, and research and development projects. Our footprint, as you can see, is almost national now. We are going international. I hope Brazil is one of our few projects. Going forward, we are into Africa, Middle East, and Southeast Asia currently. So how do we go about it? Let's see what we do in our supply chain management. And it has to be robust, because we all know a lot of people put their biomass projects and biomass power plants around the world, but the only common factor of their failure was biomass supply. They could not factor in that particular amount of cash which would burn for the lesser amount of duration when the crop is harvested, as to how this supply will be ensured throughout the year 365 days. So in our model, we create something called as village level entrepreneurs. Who are these VLEs? These are the farmers themselves who are typically underemployed or unemployed during the season after which the harvest is done. As you can see from the photographs, we have these biomass collection farms, the briquetting plant, processing and transportation. Till that point, it reaches the client. The most important part to note here is all these works are done by the village level entrepreneurs through their own resources. What we supply them is training. What we supply them is the equipment. What we supply them is microfinance. And what we supply to them is the awareness of why this activity is actually helping them in generating more income day by day. Of course, our major clients include all the big MNCs and pharma companies in the country. You can see their logos here. Hard to abate sectors like cement, we have all 3 big companies going forward. Cement and steel, which are actually utilizing biomass to the fullest for our activity. So how we do the supply chain management network, you can see the village level entrepreneur development training happening. On the right top corner, you can see a farmer. This farmer joined us 3 years back. He had hardly an income of around 25,000 rupees from his farm. Today he has 2 vehicles of his own and his car. So you can see a real rural development and an economy picking up day by day by giving them more incentives and more employment. Of course, most of these equipments today, as we know, are not market made. So a lot of them have been, as we said in India, jugaad system, but these are being very useful because most of these vehicles move in unpaved services, then come on to the paved services to the last point of delivery. So this is how these kind of vehicles are manufactured inside India and used for these particular processes. Of course, we use animal resources for our activities, as you can see. This is the kind of storage at collection centers. As all of you know, biomass is inherently ignitable. We have to maintain the temperature. We have to ensure that it is covered during monsoon seasons because the biomass has to be supplied 365 days. Fuel storage is done inside our silos. Today we have a supply strength of around 4,80,000 metric ton per year. You can see we are working with all oil marketing companies. Few of the tenders were cancelled, few are allotted, and few are under process. These are few of our photographs of the briquetting plants on all 4 sides of the country. You can see we use various biomasses for this particular activity. Here you can see cotton, corn crop, mustard and green waste being used for this particular purpose. Very nice fuel stocking and planning, and of course now biomass is also used as an utility for steam projects. We have a total steam generation capacity of 4,26,000 metric ton per year. You can see different places where this particular activity is also being utilized. On boot basis also we have our activity where we can actually build, own, operate and transfer. We also undertake the operations of the boilers from the engineering to procurement to the maintenance particular activity. Of course, since we are invested by all the major MNC companies, our EHS and safety audits are world class, and you can see our housekeeping. May I invite you all to visit our plants anywhere, anytime, 24 hours, and you will see similar kind of activity happening all day. Some of the boot projects which are now being done are in Tonsa in Punjab, a L'Oreal plant in Pune, at Dahej and Ankleshwar in Gujarat. Of course, you can see again here, it is the first in India multi-agro residual fuel capability project being envisaged. We are using here paddy straw, mustard husk, rice husk and danda kuti, basically, which is the foliage of the plants. It had a capex of around 150 million, and we cleared it during the corona period, and the plant was 100% operational in all 3 years of corona. Few pictures of the 13 TPH boiler erection which is being done. The entire EPC was done in-house. Of course, automated plant operations. We have an energy efficient certification. The new project which we have started is towards eco-cremation. It was the call given by the Prime Minister, where a lot of Hindu cremations in India happen on sourced wood which is illegal. So we have this innovative activity wherein we use agri-residue and convert it into pellets, which is being given towards cremation of bodies. You will be very happy to know that very important destinations in India which actually have a lot of religious flavor also have an adoption of around 75% today, where bodies are being cremated with 100% rice and bagasse mix kind of material. Of course, going future, we have opportunities in 2G ethanol, CBGs will replace the wood, green hydrogen, biochemicals and biofertilizers, sustainable aviation fuel. Socio-economic aspects were covered with my Brazilian counterpart. Of course, it's one of the most decentralized renewable energy which can be produced anywhere in the country. We have a lot of EHS benefits, empowers the farmers, promotes entrepreneurship and financial inclusion. Of course, Women's Day just went by. It's a picture for you. We have equal opportunities and rural economy being taken over by women. Nothing better than it for both countries' futures. 9 out of the 17 sustainable goals are covered by our company. You can have a look at this. Of course, the impact of PRESPL is on this slide. We have utilized 200,000 metric ton per year of biomass last year. Greenhouse gases reduction was to the ton of 150,000 tons, and 800 million Indian rupees were circulated into the economy, and especially the rural economy in India. Some awards have been given to PRESPL, as you can see. Not to forget to add, we have now cooperated with a global blockchain company, which is a layer 1 company, and the good part to know is it is zero gas fee. So we are employed it into our supply chain management activity. So we are sustainable on a supply chain management activity as well. I would be more happy to talk to you on this particular activity off the table if you want to. Thank you so much.
Mr. Ravi. Thank you. Cyro, Barbara, and Ankur. Yeah. I'm Amitabh, and I represent a startup from Delhi called Araville Green Energy. The topic for today has been focused around collaboration between Brazil and India on biofuels. So instead of talking about my company, based on what I have heard in this room here today, I've drawn up a list of things where I think there is an opportunity for both the countries to collaborate. And so let me start by pointing out Mr. Fernando Mosner from Anil. He had mentioned that almost 12% of the power in Brazil is being generated by micro and mini power plants. And that's about equivalent to 27 gigawatts of power. Now, to me, that's a mind-boggling figure. That's a mind-boggling figure. That sort of leads us to the question of how are they managing to procure so much of biomass to power these plants? Ankur, you mentioned this, that one of the biggest challenges for many power plants based on biofuel in India has been the backward integration problem. By that I mean that when you set up a power plant, you are able to draw a contract with the government where you agree on a certain tariff through which you get paid. But there are no backward integration with the farmer who are going to supply you the feedstock. And I'm aware of dozens of small power plants in India which have been set up, and within 5 years of their being set up, they have shut down. Not because they're not getting the money from the government, they're getting the money. But the feedstock prices by the farmers have been hiked up more than twice. And therefore, running the plants becomes unviable. So one of the queries that I have, and I think there could be an opportunity for collaboration and learning from Brazil, how is it that Brazil is managing this challenge? How is it that the prices that the farmers supply the material remain constant over, say, a 10-year or a 15-year period? Because if that prices do not stabilize, it's simply impossible to produce electricity and make money. So one of the key things that I think here, one of the learnings from this session today is to see how Brazil is doing it so successfully. 27 gigawatts is a lot of power, 12%. So that's one. The second thing which I thought was very interesting, which Barbara, you mentioned, was the use of sugarcane for ethanol, which we all know. Brazil produces such a large amount of ethanol from sugarcane. Now, I have two observations to make. In India, almost all, I would say, practically 70–80% of the power that we generate comes from coal. And in the year 2021 and 22, India consumed 1.2 billion tons of coal. Enormous amount of coal. 80% of this coal was from India itself through the mines, but 20%, the high quality coal, came from abroad, from Australia, from Indonesia, from Malaysia. Now, the challenge for India is different from the challenge in Brazil. Sugarcane is a high water consuming crop. So if you were to plant sugarcane in India on a very large scale, the water tables in India would go down further. Therefore, manufacturing ethanol from sugarcane on a very large scale in India may not be the best or the most advisable option. Having said that, even in India, the government has allowed 20% blending of petrol with ethanol. But the question is, where do you get the ethanol from? The sugar companies in India, which are large in number, produce ethanol, but they also produce alcohol for the liquor industry. And the production of alcohol for the liquor industry is more profitable to them as compared to producing ethanol for the government. They are producing ethanol for the government only because there is a mandate by the government saying that so much % of your alcohol production has to go for ethanol. Otherwise, they would rather produce alcohol for the liquor industry than for blending with petroleum. So one of the thoughts that I had, and I thought I'll share it with this audience, is that very recently in India, a trial has been made to produce ethanol from bamboo. From bamboo. Now, India grows 125 different varieties of bamboo. And after China, India is the second largest producer of bamboo. For a very large number of years, the government of India had called bamboo as a forest, and therefore the exploitation of bamboo was not allowed in India. But about two decades back, the regulation has been taken away, and bamboo can now be treated like a commercial crop. A refinery of 30,000 liters has recently been set up in Maharashtra, one of the states, which actually utilizes bamboo for making ethanol. Now, why am I talking about bamboo? One, bamboo sequesters the maximum amount of carbon from the atmosphere while it grows. It is the fastest growing grass in the world. It grows almost 12 feet in a year. And it absorbs very little water when it's growing up. It can be grown in arid and semi-arid areas anywhere. It can be grown around the river banks. It can be grown in semi-deserts. It can be grown anywhere. It's a very hardy crop. And it's a renewable crop because every third year or fourth year, you can harvest bamboo. So if you have bamboo grown on hundreds of hectares of land, after a fourth year, you get a regular cycle of bamboo available to you for making ethanol. Now, if you were to do that, you would not only save the water table from going down, you would also supplement the income of farmers because bamboo can be grown by the edges of the farms. So you can have your regular crop as well and have bamboo growing on the edges and the corners of the farm, and that can fetch you an additional income. We now have plantations of bamboo in various parts of India, including Maharashtra, which is a very big state, Arunachal Pradesh, Jharkhand, Orissa, and so on. So one of the thoughts about producing ethanol is to look at the India model, and I'm not saying that sugarcane is not a viable, of course, for Brazil it is, but for India, probably looking at bamboo as an option for making ethanol might be something more feasible. The next question that came to my mind, and because I am, or rather we, PRESPL and we both are doing a lot of biofuels, what happens after you have harvested the sugar cane from the fields? When you have harvested the sugar cane from the field, the stem of the sugar cane is taken to the factory for making sugars and thereby making ethanol. But after the sugar cane has been harvested, there's a lot of waste lying back in the field of the sugar cane farm. Now, my company has done very interesting research, and we have found that we could use this waste to produce a solid biofuel. So I will just go back a little. All along we have been talking about liquid biofuel, which is ethanol. But biofuels are of three types, as we all know. We have a liquid biofuel, which is ethanol. We have gas as a biofuel, which is the compressed biogas, which we get when we ferment vegetables and other organic stuff, and it releases methane as one of the key ingredients, and that is bottled. But we also have an opportunity for a solid biofuel. Interestingly, in most parts of the world, I have realized that hardly any attention is paid on the possibility of producing solid biofuel which can replace coal. In India, we have coal which is categorized as a bituminous coal. Now, some of you might know, coal has got 28 different categories, starting from lignite, which is the lowest, the poorest quality of coal, and going up to anthracite, which is the highest quality of coal. And bituminous coal falls somewhere in between. Now, bituminous coal gives out 3,500 kilocalorie of energy per kilogram. So therefore, if you can produce a biofuel, solid biofuel, which can give you 3,500 kilocalorie or more of heat, then you have a business case. What we did was to collect the sugarcane waste from the fields, and we used a unique process called pyrolysis. And using the process of pyrolysis, we have made a very high quality biochar from the sugarcane waste. And when we studied the quality or the characteristics using the proximate analysis and other experiments, we found that the gross calorific value of this fuel made from sugarcane waste was almost double in calorific value as compared to coal. And we also found that the emissions from this fuel, when burnt, were almost 85% lower as compared to coal. And the third parameter on which coal is measured is the ash content. So in a typical bituminous coal, almost 18-20% ash is produced, assuming that it's burnt completely. In case of the coal or the coal substitute made from sugarcane waste, ash was less than 10%. So here is an opportunity which probably can be explored both by Brazil and by India, that after you have taken out the sugarcane from the field, there is a lot of waste in the field itself. Now, what we do, we incentivize the farmer. We asked him, what do you do with this waste? And the farmer said, we burn it. So we asked the farmer, why do you burn it? Don't you realize that it's causing air pollution? And the farmer said, it cost me $4,000 to clear 1 acre of farm. And after I have cleared this farm by spending $4,000, what do I do with this waste? It's of no use to me. So why should I spend my $4,000 just to clear it from here? I might as well burn it. So then, we offered the farmer 10,000 rupees instead of 4,000 rupees. And we told him, if I offer you $10,000 instead of 4,000, will you give this waste to me? The farmer initially was in disbelief. He thought that we were joking. But then, when we actually paid one farmer, more farmers came. And today, we have a situation that we don't have the capital to pay the farmers. Almost every farmer that we know of wants to bring his sugarcane waste to us. So what we are talking about is an opportunity whereby you are not only providing a solid fuel which will replace coal. This solid fuel is carbon neutral because it comes from the field. So there is no additional carbon emission in the atmosphere, for one. Two, it becomes more energy efficient because one truck of this coal will transport double the energy as compared to what coal would transport. Because if coal is giving you 1 ton, 3,500 kilocalorie, this 1 ton is giving you 7,000 kilocalorie. The truck is the same. So your cost of transportation of energy becomes half. The ash content comes down, which means that anybody who is generating power from coal has to do lower maintenance for their plants, because the clinkers which get formed because of coal are reduced. The equipment that you need to put for catching or capping the fly ash reduces, and so on. And the volatile gases which come out from coal, that emission is reduced by 85%. So you actually can earn carbon credits on a very large scale in a thermal power plant by replacing coal with a fuel that comes from waste. So while the world has been working on the liquid fuel, and in India we have a lot of activity happening around compressed bio-CNG, and probably that's another area where probably there could be collaboration. Solid fuel made from agriculture waste is a new field where I think there is a huge amount of possibility of working together. So that's one thing which I thought. Barbara, you also mentioned one more thing, which was diesel being produced from seeds. And you also mentioned that, sustainable fuels, aviation fuel was something that is started being manufactured in Brazil. Now I see a huge opportunity for collaboration there. In India, there are many plants from which oil can be obtained for making biofuel. One of them is called Pongomia. We call it Karanj in North India, but Pongomia. It's grown in wild. It's a tree, and it's got seeds. And these seeds are collected by basically tribals. So once in a year, the seeds fall to the ground around this time of the year, around February, March, and they are collected together. And then you can actually extract oil from the seeds, and that oil can then be converted into biodiesel. And that work has already started in India. In fact, one of the companies which is doing this work has been talking to me, because after you have taken out the seed, they want me to use the shell. Why should the shell be thrown away? So we use the pyrolysis process to convert the shell into biochar. And this biochar is a carbon neutral product. It earns carbon credits. And if you mix it with the soil, it nourishes and enriches the soil. So if you add biochar to a soil, the pH of the soil becomes alkaline. For example, Punjab, which is one of the richest and one of the most fertile belts in India, the soil is becoming more and more acidic because of the yearly continuous addition of fertilizers. And therefore, the yields from crops in Punjab are coming down steadily. On top of it, you have a problem of the water table in Punjab going down because of a predisposition towards cultivating rice, which is a very water-absorbing crop. So if you were to produce biochar from the rice straw, which is there in Punjab, and put that biochar back in the soil, it does three things. One, it retains water in itself. So in subsequent productions or irrigations, you need almost 30% less water than what you would do without it. Two, the surface of this biochar has got micropores. In fact, if there is a good quality biochar, and if you were to look into the surface of the biochar, it has got a surface area, 1 gram of biochar has a surface area bigger than a football field. 1 gram of biochar has a surface area bigger than a football field. So these micropores actually capture the water and also capture the nutrients from the fertilizers that you've put. Because the fertilizers, with the water, they get run off, and once they've gone beyond 6 or 8 inches underground, they become useless. So these micropores capture the nutrients, capture the water, and they allow microorganisms to start growing around those pores. And these microorganisms not only provide immunity, strengthen the plant, they also help it in absorption of the nutrition from the soil. So a biochar is a new concept, very new in India. It's not so new in the West. Biochar is becoming bigger and bigger in Europe and America. But I think there's an opportunity for Brazil and India to see how we can work together to make biochar. We have an opportunity to see how we can work together to make sustainable fuels for the aviation. And we have an opportunity to work together to see how we can make solid fuels which can replace coal. Thank you so much.
Yeah, if there are any questions from the audience?
May I make a comment?
Oh, yeah, sure.
On the last presentation of Mr. Malaviya. I fully agree with you. You need not only to copy the experience from one country from the other, but look at the opportunities and challenges do you have in your own environment, okay? When Brazil started up a large sugarcane production of liquid ethanol, we had the opportunity to do that because we had that sugar plants, whole-scale sugar plants already installed, and we had the opportunity either to extract liquids and use the rest of the bajur to produce, to burn and produce bioenergy. So we had, we look at the whole chain of challenges and opportunities, what we had available, and worked with we had by that time. Later after, we started looking for other alternatives that had other advantages and would be the second generation opportunities. Like we are using biodiesel, now we are looking for other types of bio, and Barbara is exactly working to better accommodate the available materials to new opportunities. In Brazil, I tried personally to start some briquette. Companies we helped in early 2000s to discuss some briquette business like our colleague here successfully developed. It was a tremendous problem because transportation would be made with hydrocarbon. So this was a question of looking how we are processing the whole cycle. I agree with you. We need to better use the available feedstock that we have. You are doing greatly here. We saw an enterprise that brings the small producer to links all the chain to the village. And also these other available opportunities. I think there are excellent fields for collaboration. I think that there should be some research. I'm not aware of how far you have already made available those options as a business scale, but I think we would be glad to work together in those other opportunities. You have a very large, broad opportunities that you already mapped, and try to make them true and sustainable for you. And I agree, you have a massive challenge to change your electricity production, maybe with another solid biomass solution rather than the liquid one. Thanks for that. I think this was an excellent section because we try to present our experience and the trends that we are trying to advance. And you came with proper challenges that can be present other alternatives that we are researching now. So I don't know, Barbara, if you want to complement.
Yes, you mentioned the bamboo, the possibility of bamboo. I believe in this moment I now remember one study with bamboo for biodiesel or ethanol, but it's possible. It's possible because the bamboo are high specific heat. The bamboo grow the 1 meter for day. 1 meter for day.
Yes.
The bamboo is
Fast growing.
Yes, very fast growing.
fast, but existing in the world more of 100 species of bamboo. It's possible sometimes species to produce the biodiesel, biofuels, or ethanol, because it's necessary research. I learned in my cellular you talking about bamboo, recent studies in Hungary with the 2 species of bamboo. We talked for you after the meeting for collaboration, agreement, and the possibility with research. India, you and the UNICAMP, you are the other research.
Thank you so much. Thank you. Any questions? Yeah, please.
My question to Amitabh, sir. Sir, you spoke about the bamboo and ethanol production. It has been learned that bamboo contains lead and other heavy metals. So during the process, the last, say, kilo of waste, how do you process it, sir?
When you grow bamboo naturally without the additions of fertilizers, etc., which is what is happening mostly. If you look at the northeast of India, look at Assam or Nagaland or Arunachal, or you look at the eastern part of India, Jharkhand, Orissa, Chhattisgarh, all these areas, the bamboo grows naturally. Because of the moisture in the soil and the quality of the soil, it grows naturally. And when you grow it naturally, we have done detailed testing of bamboo and the char. And on a one-to-one basis, I can share the results with you. But there has been practically no traces of lead in the bamboo, or to that matter, traces of any heavy metals in the char that we have made. There's been a trace of sulfur, maybe 0.01%, which is well below the tolerance level that is accepted. You know? So, yeah, so our experience with bamboo has been excellent. And this is one crop which is available throughout the year, which Ankur also mentioned, because it's a cyclicality. I mean, it grows, and every third year or fourth year, you can harvest bamboo. And you had mentioned, Barbara, about R&D to make it better yield for sugar. Same way, there are some scientists in India who have done a lot of research on bamboo, and they have developed a particular variety of bamboo through tissue culture, which can actually be harvested in 2.5 years instead of 4 years. And you get better yield from them. And in fact, that variety of bamboo is now being taken out of India into bamboo areas such as Vietnam and Thailand. Even there, the workshops are being done by this scientist and his team to promote this fast-growing, high-yield bamboo. So, like I said, the beauty about bamboo is that it sequesters or absorbs the highest amount of carbon from the atmosphere while it grows. Second, it's a fast-growing crop, 1 meter a day. So next day you see it's grown. And it absorbs or needs very little water to grow, which means that you are able to retain the water table, which is the biggest problem, one of the biggest challenges for India, across India, is the water table going down. I mean, we talk of the IT and everything. I'm sure you must have read what is happening in Bangalore right now. I mean, except for drinking water, you have no other water, practically. There's a ban on water. 20 years back, and we were living in Bangalore, and I've lived there for a long time, it was full of lakes. But collusion, I'm sorry, I don't want to comment, but collusion between politicians and real estate developers has meant that the lakes have disappeared and towers have come up on lakes. So I can see, I could sense a lot of opportunity. I didn't even talk about so many other things. For example, the flex engines that you've talked of. I was having tea outside and I was chatting with a friend of mine, and he says, how is it that Brazil is able to do 27-30% ethanol blending? Because according to us, beyond 20%, ethanol blending would require a different kind of a mechanism, device, or motor. And that's where I got the answer, that you have a different technology altogether called flex. Yes. Now, and you also mentioned Mahindra. So I can see a synergy. Why can't Mahindra bring flex into India? I'm not representing Mahindra, but I'm just saying that so there are many opportunities. Many years back, SpiceJet had flown a flight which was on sustainable fuel, aviation fuel. But that was the only flight that I've heard of. So sustainable aviation fuels that can be made from biofuels is a huge opportunity area. Solid fuels, which can replace coal, is a huge opportunity area. Making biochar, which can be sequestered in the soil and improve the soil quality. I'm sure even in Brazil that challenge would be there, and therefore that's an area of collaboration, and so on. So huge opportunities, and thank you for giving us so much information. I hope I have answered your question.
Thank you.
Any other comments, questions? Okay, otherwise I'll close. Thank you all very much for your insightful comments. I also think that the second part of this workshop also is a big success towards that MOU 5 points. It is my hope that either through the industries such as Mahindra's or through the academic side or through any one of your entrepreneurial side, we continue the discussion. And anyway, there is a framework between India and Brazil. And so now the question is, we need to go to the right ministry and see who are all the players and what is the mechanism between India, Brazil on the biofuel side. So I think with that, I would like to give a nice round of applause for all our speakers here.
Thank you, esteemed speakers. We'll have a quick group photograph with mementos to our esteemed speakers. Kindly, please, sir. Barbara. Mr. Amitabh. Mr. Amitabh. Thank you, Mr. Amitabh. To Mr. Ankur Naik. Mr. Cyro. Cyro, you can I'll hand over the memento to Mr. Ravi. We'll close the session. Thank you everyone for participating. Thank you. Bye-bye.